Welcome one and all to another one of my structural engineering demonstrations. My name's Bob Johnson. I'm a retired structural engineer in Chicago, and for 30 years I've been doing outreach efforts to children to show them what structural engineers do. In these days of COVID, I haven't been able to get into the schools or do STEM activities, various expos, so I'm here to show you with this simple presentation a little bit about triangles. Here we have a triangle. As you can see, it can't move. Engineers call this a right triangle because this is 90 degrees. Triangles come in all kinds of shapes. This one's equal in sides. It's an equilateral triangle. Again, notice you can't get it to move. Engineers love to use triangles in their buildings and bridges. Take a look at me. I'm wearing probably one of the most famous structures in the world, the Eiffel Tower. The Eiffel Tower has hundreds and hundreds of triangles in it. But if we didn't have triangles, we have other shapes. And let me take a look at this shape. Maybe you know what this is. This is a parallelogram. But you can't keep it straight. Here we got it in the shape of a rectangle. Engineers don't like to use rectangles in their structure because they move. However, notice what we can do here. If I take this member here and add it and form triangles, now this structure won't move. So this is the importance of triangles. When you get to high school, you'll have a whole course on the study of triangles. Since it's very important to engineers, engineers of course are going to have to take that course in trigonometry. So let's take a look at how structures use triangles. Back in my collection here, I have all kinds of buildings and bridges, some of them using triangles. Here's one of my simple models. As you can see here, I have a triangle shape. Let's see how it does if we put it on some supports. Let me move these triangles away. And we put it on our supports here. And now I'm going to load it up and see how this triangle here behaves. And you'll notice my structure here starts to sag. And I add more weight on it, and it's sagging even more. Notice the triangle here. This member here in the triangle shape can't carry the weight. It's in compression. Engineers, when they're doing designs in their triangles, have to check to see how much compression is in the triangle or tension in the triangle. If it doesn't has too much compression here, it can't carry the weight. So let's take the same model and flip it over. The same actual model, we'll flip it over, and now we can start adding some weights to it. Notice what's happening here. We have a triangle here, but down here, that string before was in compression, now it's in tension. The load goes down here, comes back up here, and is carried. So this gives you the importance of triangles in bridges. We'll have more in another presentation later, but for now I just wanted to show you the importance of engineers using triangles in their structures. Again, if you want more information, go to the Structural Engineers Association of Illinois. Their website is www.seaoi.org. My name's Bob Johnson. I have a Twitter handle of Engineer Guy SE, or look into the future for more of my postings on structural engineering on YouTube. Again, using the handle Engineer Guy SE.